Hey guys, welcome to the notes for perpendicular lines. We are in Unit 4. Our essential question is, how can you tell if two linear equations are perpendicular? So previous to this, we talked about parallel lines. And what do we know about parallel lines? Well, they have the same exact slope. If I were to graph them, they would have the same exact slope and they would never intersect each other. With perpendicular lines, these lines are going to intersect each other, but they intersect each other at a special angle. So, what are perpendicular lines? Well, perpendicular lines are lines that cross, or that intersect actually, /cross, at a 90-degree angle. Okay, so these are perpendicular lines, are lines that intersect or cross at a 90-degree angle. So just because two lines cross does not mean that they are perpendicular to each other. Okay, so you want to be super careful that you don't just say, oh, they cross, they're perpendicular. So the mathematical symbol for perpendicular, by the way, looks actually like an upside down T. And the reason why it looks like an upside down T is because if you'll notice, it makes a 90-degree angle right there. So it's a 90-degree. And remember that previously we learned about parallel, and the symbol for parallel is that one. So when you move to geometry, you're going to be seeing symbols like that. Now for parallel lines, those are lines that have the same slope. They're never going to intersect. Perpendicular lines do not have the same slope, but they do intersect at a 90-degree angle. So if you want to draw yourself a little picture, kind of to help you see, we could draw one that looks like this. And you want to make sure that when you draw it, you make sure that it intersects as best you can at 90 degrees. So you're going to have a 90-degree angle here. Those are going to be perpendicular lines. Here's an example of not perpendicular. Okay. So here's two lines here. Now these two lines, they cross, but they are not perpendicular because they do not cross at a 90-degree angle. So you want to make sure that you are aware that when you see perpendicular lines, it's not just because that they cross. Okay, you have to make sure that it is 90 degrees. Now, we're not in geometry. We're not measuring angles. We're not doing anything with degrees. So how can I tell algebraically if two lines are perpendicular? Well, again, just like with parallel, you're going to look at their slopes. But the slopes of perpendicular lines are not going to be the same. They're actually going to be called opposite reciprocal slopes. So I'm going to go ahead and explain what that means in a second. We're going to go ahead and just write that down. They're opposite reciprocal slopes. In math, opposite means opposite sign. So if your first slope is positive, in order to make a perpendicular slope, you would have to change it to a negative. And vice versa, if it was a negative, you would change it to a positive. Reciprocal in math means you're going to flip a fraction. So if you have the fraction 2/3, you would flip it and make it into 3/2. So opposite means opposite sign. Reciprocal means you flip the fraction. With perpendicular lines, in order to have a perpendicular slope, you must do both. So we're going to practice really quick with some different types of examples. So our first example here is going to be, can I use blue? Have I used it yet? I have not. Okay. Example number 1. Let's say that one of my equations has the slope 1/2. The slope of my equation is 1/2, and I have to make a perpendicular slope to this equation. If I want a perpendicular slope, I don't want to use the same one, because if I use the same, I'm making parallel. So I want an opposite reciprocal slope to 1/2. Well, opposite means I would change the sign. So the 1/2 is positive, so I know that my new opposite reciprocal slope is going to be negative, and then I would flip the fraction. So instead of having 1/2, I would have negative 2/1. Now you're always going to simplify if possible, so negative 2/1 simplifies to negative 2. Okay, so negative 2 and 1/2 are opposite reciprocal slopes of each other. Another example. Okay, so you want to change the sign and flip the fraction. You must do both or your slope will be incorrect. Next example is going to be negative 2/3. Actually, I'm going to use a different number, negative 3/4. Let's do that. Okay, I want to create a perpendicular slope to the slope of negative 3/4. Now, if I wanted to make a parallel slope, then it would just be negative 3/4. I want to use exactly the same if it was parallel, but for perpendicular, you want opposite reciprocals. So because this first slope is negative, I know that my new slope is going to be positive, and then I'm going to flip the fraction, so instead of 3/4, it's going to be positive 4/3. So these are opposite reciprocals of each other. Okay, those are opposite reciprocal slopes. Okay, we're going to have one more example. Now this example we do tend to mess up sometimes, so we're going to be super careful with this. And I'm going to give you negative 5. Okay, I want the opposite reciprocal slope to this. If I give a slope of negative 5, I want to figure out, Well, what would my opposite reciprocal slope be? What do I know? Right now it's negative, so I know my new slope has to be positive, right? It's going to be positive. But what about the number part? Well, it's actually positive 1 over 5. Now, where'd that 1 come from? Well, technically, if I write negative 5 as a fraction, it's technically negative 5 over 1, right? So it was negative, so now it's positive. And then you flip the fraction. So instead of having 5 over 1, you now have 1/5. So that's going to be something that's going to be tripping up some people. So this one is actually a super important one. Remember, the whole numbers always have a 1 underneath technically. Okay, so we're actually going to start. The notes are set up very similarly to the parallel lines notes, so you'll see some similar examples. Are the following lines perpendicular? Okay, now the easiest form for me to see the slope of any equation is when they're in the form of slope-intercept, y equals mx plus b. The reason why it is easiest to see if the slope here is because your slope is always going to be attached to x in slope-intercept form. So the goal is the same as when we did parallel. Get the y by itself, and then look at the slopes, and then you can determine, are they parallel, are they perpendicular, or is it really neither? All right, so let's go ahead and start with number 1. Now again, you want it to be in slope-intercept form, so you want y to be by itself. Do I have to do any work with number 1 to find the slope of either equation? No, they're already in slope-intercept form. I literally have to do no work. So with the first equation, what's my slope? My slope here is 3, so my slope is going to be positive 3 here. The slope of the second equation, I already know because y is by itself. The slope here is negative 3. Are these lines perpendicular to each other? The answer is no, because in order for them to be perpendicular, they must be opposite reciprocals. They're opposite, right? One's positive, one's negative, but that's not the reciprocal. They didn't flip the fraction. So if I wanted the opposite of reciprocal of 3, it would have to be negative 1 over 3. You'd have to flip that fraction. So these are not perpendicular because they're not opposite reciprocals. So not perpendicular. Are they parallel? They're not parallel either. What would make them parallel? Well, they would have to be exactly the same. And one's positive, one negative, so they're not exactly the same. They have to be exactly the same to be parallel. So they're not parallel, they're not perpendicular. They just happen to be two lines that cross, and there's nothing really special about them. So we're going to move on to the next one. Number 2, y equals negative 2x plus 6, y equals 1/2 x minus 4. Now, do I know the slopes of both of these equations without doing any work? Yes, because y is by itself, they're both in slope-intercept form. So the slope of my first equation is negative 2, because it's attached to the x. The slope of the second equation is positive 1/2. Are these slopes opposite reciprocal? Yes. That means that if they're opposite reciprocal, then they are indeed perpendicular. Now, why are they perpendicular to each other? Well, if I have negative 2, and I want to make it opposite reciprocal, then the new one would have to be positive, right? And then I would flip the fraction. Right now it's 2 over 1, so it'd be positive 1 over 2, which is exactly what I have in the second one. So these are opposite reciprocals of each other, so they are perpendicular. Moving on to number 3, we have y equals 2 minus 5x and y equals 5x minus 2. In this case, again, I already know my slope because the y is already by itself in both equations, so I don't have to do any work to find the slope. The slope of the first equation is going to be negative 5. Remember, it's attached to your x. You want to be super careful about that. It's not always the first number that you see. And then the slope of the second equation is positive 5. Well, these slopes are not exactly the same, so they're not parallel, that's for sure. Are they perpendicular, though? They are not. They are not opposite reciprocals, so this would be not perpendicular. Now, just because they're not perpendicular does not mean that they're parallel, right? So these are not parallel either. So you don't want to say that they're parallel. Okay, number 4, y equals 2/3 x plus 1 and 3x plus 2y equals 6. Now, with the first equation, I already know the slope because y is by itself. But in the second equation, y is not by itself, so I do not know the slope. So because I do not know the slope of the second one, I have to get y by itself and then determine what the slope is. But because I already know the slope of the first equation, I'm going to go ahead and identify it. The slope for the first equation is going to be positive 2 over 3. Okay, now let's go ahead and get the y by itself in the second equation. The first thing I'm going to do is I'm going to subtract 3x from both sides because I'm trying to get y by itself. So I have 2y equals 6 minus 3x. Now the next thing I want to do is I want to get y all by itself, so I'm going to divide everything by positive 2. 2 divided by 2 becomes 1. It's just cancels. We have y equals 6 divided by 2 is 3. And then negative 3 divided by positive 2 is negative 3 over 2. And then we have the x. So why did I do this? Remember, I'm trying to get y by itself so I can determine what the slope is without having to accidentally call it 3, because it's not 3. So what is our slope here? Our slope here is negative 3 over 2. So looking at the two slopes that we have, so negative 3 over 2. Looking at these two slopes, would you say that they're perpendicular to each other? Would these two lines be perpendicular? The answer is yes. They are perpendicular to each other. How do I know that? Well, remember, for them to be perpendicular, the slopes have to be opposite reciprocals. Opposite means one's positive and one's negative. So because this one was positive, this one's negative, so that checks out. And then you want to flip the fraction. Because this was 2 over 3, the new one has to be 3 over 2. You got to flip the fraction in order for it to be opposite reciprocals. So these are perpendicular. Okay. Moving on to actually writing some equations. So writing equations of perpendicular lines. Write an equation of the line that goes through negative 2, 3, and is perpendicular to y equals 1/2 x minus 6, or not minus 6, minus 1 in slope-intercept form. So these problems are set up very, very, very similarly to the problems from parallel lines. There's just one word that's different, and the word that's different here is perpendicular. With parallel lines, I wanted the same slope. I wanted to use the same slope of the equation that they gave me. But with perpendicular lines, I do not want to use the same slope, because if I use the same slope and I create a parallel line, I can't give you any credit because you have not created a perpendicular line. You actually created something completely different, which was parallel. So with perpendicular slopes, you want to remember perpendicular lines, very fast. With perpendicular lines, you want opposite reciprocal slopes. You do not want to use the same one. If you use the same one, you will create a parallel line on accident, and it will not be a pretty time. Okay, so you're going to write an equation. So that means at the very end, I'm going to have an equation, and you want it to go through the point negative 2, 3. So I know that it has to go through that point. So I have the point negative 2, 3. And then I have this equation over here. Now, we want it perpendicular to this equation. Well, this equation here, I got to first identify the slope. Do I know the slope without doing any work? Yes, y is by itself, so it's already in slope-intercept form, y equals mx plus b. So my slope here is positive 1 over 2. Okay, I already know the slope. The question is, I'm going to move this down. Would I use this slope to create my new line? The answer is no. Why would I not use the same slope? Well, if I use the same slope, what kind of line are you making? You're making a parallel line. And what kind of line are they asking you to make? They're asking you to make a perpendicular one. Perpendicular lines do not have the same slope. So this is what you're going to do. Always identify the slope of the current line that you have. So the slope right now is 1/2. And then right underneath that, you're going to write new m to remind yourself that you have a new slope. You cannot use the same slope as you had, because if you use the same one, it's parallel. This is super important because you're going to go on autopilot and you're going to use the same one every time because you're going on autopilot. And if you do that, you're going to get 50% of the problems wrong, because if they're asking for perpendicular and you're doing parallel, it's going to be very bad. So what will your new slope be? Well, if you have positive 1/2, then you need an opposite reciprocal of that, which would be negative 2 over 1, correct? So your new slope is negative 2 over 1, and you're always going to simplify if possible. So what does negative 2 over 1 simplify to? It's going to simplify to negative 2. So you have your slope, your new slope, right? You do not want to use the same one. So the old one is gone. You don't want to use it. So you have your new slope, and you have the point that it has to go through. So you're going to go to point slope form. Just like with parallel lines, you're going to do the same exact process. You have y minus 3 equals negative 2, x plus 2. And I'll go ahead and color code these so we know exactly what these came from. So this was this was from the point, green, and then this is our slope. All right, so the negative 2 are our new slope. We don't want to use the same slope that's red. We want to use the new yellow one. And then we're going to plug in our point, and remember, when you plug it in, you have opposite signs. All right, now we're going to distribute, because what kind of form do we want our final answer to be in? We want it to be in slope-intercept form when we finish this. So slope-intercept form is y equals mx plus b. So in the very end, we want this to be in slope-intercept form. So first step is we're going to distribute. We have y minus 3 stays the same. Negative 2 times x is negative 2x. Negative 2 times 2 is negative 4. Okay. Then the final step here to get y by itself to get to slope-intercept is to get rid of that negative 3 by adding it to both sides. And remember, you can only add to like terms. So we have y equals negative 2x, and then negative 4 plus 3 is negative 1. Is this in slope-intercept form? Yes. So you have made an equation that is in slope-intercept form that is perpendicular to the original equation. So I'm going to go ahead and graph this to show you what we just did. So they give us the point, I forgot already, they give us the point negative 2, 3. Okay, and then they gave us the equation y equals 1/2 x minus 1. Is that correct? 1/2 x minus 1. Okay, so they're giving us that blue line, right? That's the equation, and then they gave us that red point. They said they want you to make a perpendicular line to the blue one. So that means that they want you to go through this red dot, but want it to be perpendicular to the blue. So it's going to be a line that cuts through it like this. So let's check to see if our equation that we made makes sense. We have y equals negative 2x, and then what was the other part of it? Minus 1. And if you look, the green line and the green and the blue lines are perpendicular to each other, and your green line goes through the red point, which they asked you to do. So that's essentially what we're doing today. It's the same exact process as the day before, except you're not using the same slope, you're using a different one. Moving on to number 2. Write an equation of the line that it goes through negative 3, 2, and is perpendicular to x minus 3y equals 7 in slope-intercept form. Okay, so I know in the very end that my equation has to be in slope-intercept form, so I'm going to go ahead and remind myself of that. Everything is super important that's written because it can be very hard or very easy to just look at the numbers and then just go autopilot. All right, they gave us the point negative 3, 2, so I'm going to go ahead and point that out down here. That was a horrible pun. Okay, so I'm going to put down negative 3, 2. That's the point that they want me to use. Now they're asking me to create a perpendicular line. So what kind of line? Perpendicular. If they're asking me to create a perpendicular line, am I going to use the same slope? No. When would you use the same slope? When you're learning or when you're writing a parallel line. So you're going to have an opposite reciprocal slope here. So please do not use the same slope on accident, because if you do, you've created a parallel line. Okay, so question is, do I know the slope of this current line? I do not. Y is not by itself, so I do not know the slope of this equation. So the first thing I need to do is get y by itself. So I'm going to first subtract x on both sides. Actually, I'm not going to use this pink. I'm going to use lavender. I'm going to subtract x on both sides. So I have negative 3y equals 7 minus x. Now I got to get y by itself. So I'm going to divide everything by negative 3. Okay. Now here's where we can make some mistakes. So just make sure you're following along right now. So the negative 3 divided by negative 3 is y. 7 divided by negative 3 is negative 7 over 3. Here's where the mistake is. Where can I use baby blue? We haven't used baby blue. Okay. Negative divided by negative. Now, what number is in front of that x? What number is in front of that x? There is a 1 here. So you have negative 1 divided by negative 3, which is positive 1 over 3. If you get this sign wrong, it's going to cause a lot of issues in the end. So please be careful with that. So you have positive 1 over 3x. Okay, where'd the positive come from? Remember, a negative divided by negative is a positive. And there's a 1 in front of that x, so that's where that 1 comes from. So question, do you know what the slope is now? Yes. What's the slope? The slope is positive 1 over 3. Is this your answer? Is this equation your answer? No. You literally haven't done anything. You haven't even used the point that they gave you. All you did was just convert from this equation into slope-intercept. So you haven't actually done anything. So that's not your answer. So what do I need to do? Why did I do all of this? I did all of this work to identify the slope. Why do I need the slope? Because I'm trying to create a new equation. The question is, would I use this slope to create my new equation? Answer is no. Why do I not want to use the same slope? Because if I make it with the same slope, I make a parallel line. I'm asked to create a perpendicular line, so we are not going to use the same slope. So that's the slope currently. Now I'm going to identify the new slope that we're going to use, nu m. Your new slope, not the old one. So if the old slope was positive 1 over 3, the new slope is going to be negative because it's opposite sign, and then you're going to flip the fraction negative 3 over 1, which simplifies to negative 3. You have your new slope Okay, why are we using a new slope? Because it's perpendicular, you need opposite reciprocal. When you're taking a quiz or a test, you're going to be asked to create parallel and perpendicular lines. So it's super important. You're like, do I use the same slope or do I need to do opposite reciprocal? Always ask yourself that. Okay, so we have a point and then we have a slope. So we're going to use point-slope form. So we have y minus 2 equals negative 3, x plus 3. All right, so let's go ahead and simplify this because we need this in slope-intercept form. Negative 3 times x is going to be first. So y minus 2 equals negative 3 times x is negative 3x. Negative 3 times 3 is negative 9. Then the next step here is to get y by itself by adding 2 to both sides. So we have y equals negative 3x. Negative 9 plus 2 is negative 7. This is in slope-intercept form, so then this would be my final equation. Oops, that's very crooked. Okay, so that's our slope-intercept form equation. Now again, should the slope of this line be the same slope as the line that you had earlier? No, they should be opposite reciprocals of each other because you made a perpendicular line, not a parallel. All right, moving on to number 3, write an equation of the line that goes through 4, 5 and is perpendicular to 3x plus 2y equals 10 in slope-intercept form. Now hopefully, if you want to, you could probably try this one on your own. So if you want to pause the video and try it on your own, that would be great. But the first thing I'm going to do is I know that it has to go through the point 4, 5. So I'm going to identify my point down here. I need to use the point 4, 5 when I'm making my new equation. Now I want to make a line that is perpendicular. So that's important. I'm going to highlight that. And I know that with perpendicular lines, I'm going to use the opposite reciprocal slopes, not the same one. I don't want to use the same one because if I use the same one, what kind of line am I making? Parallel. I also know that my equation at the very end needs to be in slope-intercept form, so that's going to be y equals mx plus b. So I'm going to make sure that my end equation looks like that. Now, I know the point that I have to use. I don't know the slope yet, so let's look at this equation. Do I know the slope of this equation? I do not. Y is not by itself. It's not in slope-intercept form, so I have to get y by itself. And the first thing I'm going to do is subtract 3x from both sides. So then I have 2y equals 10 minus 3x. Now I got to get the y by itself, so I'm going to divide everything by 2. 2 divided by 2 cancel, so I have y equals 10 divided by 2, which is 5. And then negative 3 divided by 2 is negative 3 over 2. X. So, what is the slope of this equation? Because y is by itself, so I should know the slope. The slope here is going to be negative 3 over 2. Would I use this slope to create my new equation? No. If I use the same slope, or when would I use the same slope, really? When would I use the same slope? When making parallel. But I want to make perpendicular, so I'm not going to use the slope. I'm going to go ahead and identify my new slope. Okay, now I need the opposite reciprocal. So because it's negative 3 over 2, the new one is going to be positive 2 over 3. So this is my new slope, and I have the point that I need to have it go through, 4, 5. So I'm going to start in point slope form because I have a point and a slope. You always start in that form if you're only given a point and a slope. So you have y minus 5 equals 2/3 x minus 4. Okay. So next step here is to distribute because we're trying to get it to slope-intercept. Y minus 5 equals 2/3 times x is 2/3 x. 2/3 times negative 4 is negative 8 over 3. And then the last step here is going to be getting y by itself. So I'm going to add 5 to both sides. And so I have y equals 2/3 x. And then negative 8/3 plus 5 is going to give me positive 7/3. So this is my new equation in slope-intercept form. And I'm going to double check that I added my fractions correctly over there real quick. So negative 8/3 plus 5. Yep, positive 7/3. Okay, yeah, so that's our equation. All right, now the next 4 problems are pretty similar to the same section as the day before with parallel. However, the last 2 are going to be a little bit different, so it is important that you pay attention to those. So write an equation perpendicular to the x-axis and goes through the point 3, negative 1. All right, now this is not a normal problem. Why is this not a normal one? They didn't give us an equation, and when it's not normal and they don't give us an equation, and we can't do it in our heads, then what's the best method here? Draw yourself a graph to help visualize this. Now, I already drew a graph from doing parallel lines, so I have my graph here. Okay, I'm going to go ahead and copy this. Okay, so I already have my graph. We're asked to write an equation, so I want to make sure that at the very end I have written an equation. Don't just, draw the picture and then don't actually write an equation. Now you want this to be perpendicular. So when you draw later, you want it to be perpendicular, so it should cross whatever they want you to have it cross. They want it to be perpendicular to the x-axis. So I'm going to highlight my x-axis real quick, so I know that it has to be perpendicular to that one. Okay, and then they want the line, they want it to go through the line 3, -1. So I'm going to plot 3, -1, which is right here. So, question. When I'm writing this equation and when I'm making this green line, would the line go up and down or side to side, left to right? Now the reason why it's going to be up and down is because you want it perpendicular. So the x-axis is highlighted in yellow. You want the new line to be perpendicular to that yellow line. So would you make your line straight up and down like this or side to side like this? Well, if I made it left to right, it's actually never going to cross the yellow line, and you've actually made a parallel line. If you want a perpendicular one, you want it to cross. So you're going to draw a line that actually crosses through the x-axis because you want it perpendicular to the x-axis, and you want it to go through that green point. So it's going through the point 3, -1, and it's perpendicular to the x-axis. So we're going to write the equation now. The green line goes through which axis? It goes through the x-axis, so it's going to be x equals, and it goes through the x-axis at +3. So you have x equals 3. That's it. That's all you have to do for that one. All right, write an equation perpendicular to the y-axis, and it goes through 2, -4. Again, this is not a normal problem, so you're like, okay, if I'm not given a normal equation, let me draw a visual for myself to help visualize this a little bit better. Okay, you want to write an equation at the very end, so make sure that there is an equation that you wrote. And you want it to be perpendicular. Yesterday you had parallel. Parallel means I don't want the lines to touch. Now perpendicular means I do want them to cross, and I want it to cross the y-axis. So I'm going to highlight my y-axis, and then I want my line to go through the point 2, -4. So 2, -4 is going to be located right here. Now it's going to be super important that you plot that point in the right spot, because you're going to end up drawing the line in the wrong spot if it's not in the right spot. Okay. You want to draw a green line that's perpendicular to the y-axis. So your y-axis runs up and down. Okay, the y-axis is yellow, up and down. You want your line that's green to run perpendicular to it. So you want it to cross. So would your line be up and down like this or side to side like this? It's going to run left to right. You want it to cross the y-axis because you want it to be perpendicular to it. So the line's actually going to run left to right. It's actually going to be a horizontal line, which has a 0 slope, by the way. Okay, so we're going to write our equation. What axis does this green line cross? It crosses the y-axis, so it's going to be y equals, okay, and it crosses the y-axis at the number -4. So your equation is y equals -4. All right, moving on to number 3. Write an equation that is perpendicular to x equals 4 and goes through -1, 2. Now, we haven't seen this type of problem yet before, but does it look normal? Does this look like a normal equation that we normally get, right? Because they're giving us an equation this time, but it's not exactly normal, because typically with equations we have an x and a y, and here they only gave us an x. Remember, if the problem does not appear to be a normal problem with a normal equation that has an x and a y, draw yourself a picture to help guide you. So we know that we're going to have to write an equation in the very end. We want that equation to be perpendicular, so we want it to cross x equals 4. And I'm going to highlight that. I'm going to highlight x equals 4. Why not? Okay. And then we want it to go through the point -1, 2, not 3. So let's go ahead and plot -1, 2. So -1, 2 is going to be located right here. Now I'm going to graph the line x equals 4. So how would I graph this line here? Well, x equals 4 is going to be on the x-axis. Okay, so you're going to go to the x-axis at +4. And it's going to be a line that goes through that. Now you see how the tick mark goes up and down like this? Well, that line is going to go straight up and down. Okay, now we haven't done anything. We literally just plotted the information they gave us. So they told us x equals 4, and they gave us the point -1, 2. So this is what they're telling us. They want us to create a line. They want us to make the green line that goes through this green dot to be perpendicular to this yellow one. Okay, so x equals 4 is the yellow one. They want us to make a perpendicular line. So if I want to make it perpendicular, do I want it to intersect? Yes. So when I make this line, should the line through the green go up and down or left to right? It should go left to right. It should cross. We want it to be perpendicular to the yellow line. We want it perpendicular to that yellow line that's going up and down. We want it perpendicular because it tells us perpendicular. And then we want it to go through that green point. All right, so we want to write the equation. Now, the yellow line is not the equation, right? That's what they gave us. The line that we're writing the equation for is that green one. So the green line crosses which axis? It crosses the y-axis, so it's going to start with y equals, and it crosses the y-axis at positive 2. So our equation here is y equals 2. Okay, and that's it for that one. Write an equation that is perpendicular to y equals negative 3 and goes through the point 4, 2. Now again, this is not a typical equation that we normally see. We normally see an x with the y in there. When it's not typical, when it's not normal, you're going to draw yourself a little graph to help guide you. Okay, you don't have to do this if you can do it in your head, but you don't want to make a mistake on accident. You know in the very end that you have to write an equation. So remember, this picture is not your answer. This is just to help find the answer. It's basically kind of like your work. Now you want it to be perpendicular, so you want it to cross y equals negative 3. You want it to cross that. And then you want, your new line to go through 4, 2. So let's go ahead and plot 4, 2. So 4, 2 is going to be right here. Okay, so remember, you want to make sure you plot that point in the correct spot. And then they gave us the line y equals negative 3. So let's go ahead and graph that line. So I'm going to go to my y-axis because it says y equals, and then I'm going to go down to negative 3, so that's going to be right here. So I know that that line that they're giving me is going to run side to side, and the reason why I know that is because these tick marks run side to side. Okay, now I haven't done anything yet. I'm only just plotting the information they've given me. So they want me to create a line or create an equation that goes through that green point that's perpendicular to that yellow line. So the yellow line's running left to right. So for my green line, would I want it to run left to right as well, or would I want it to run up and down differently? Okay, if I make my line run left to right like this, what kind of line did I make? I made them parallel. I want them to be perpendicular, so this line's going to go straight up and down through that yellow one. Let's go ahead and write the equation. Okay, so writing the equation, you're going to look at the axis that it crosses. So my green line, right, the green line is the new one that we created, crosses the x-axis, so it's going to be x equals, and it crosses the x-axis at positive 4. So the equation for this line is going to be x equals 4. All right, we're down to our very last problem in these notes. Yay, we made it. Okay, so write the equation of the line perpendicular to the graph shown and goes through negative 3, 1 in standard form. So I know that in the very end, my equation must be an ax plus by equals c. Not point slope, not slope intercept, standard. Okay, now I know I have to write the equation of a line perpendicular. Now, perpendicular lines, what kind of slopes do they have? They have opposite reciprocal slopes. If they have an opposite reciprocal slope, do I want to use the same slope as the original? No. If I use the same slope, what kind of equation did I make? I made a parallel line. You do not want to make a parallel line. You want to make it perpendicular. It is very easy to go autopilot and then make a parallel line on accident. So you want the opposite reciprocal slope. Okay. Now, I know that I have to go to the point negative 3, 1 in the end. So that's the point that I have to use. So the point is negative 3, 1. I think I said that. Hopefully I didn't say 2. I think I might have, but it's okay. We wanted to go through the point negative 3, 1. Now let's go ahead and find the slope of this line. So I see that there's 2 solid points here, and I'm going to use rise over run, and I'm going to start at this bottom point for my rise. So we have rise over run. Okay, my rise is 1, 2, 3. I went up, so it's going to be positive 3. And then my run is going to be 1, 2, 3, 4. Now, it's going to be negative 4. Why is it negative 4? Because I went to the left. I went 4 to the left. You want to make sure that you don't just go autopilot and count, right? You want to make sure you're paying attention to the directions you're counting. So your slope is negative 3 over 4. Here's the question. Would you use this same slope when creating your new equation? Would I use this slope? No. Why do I not want to use the same slope? Because if I do that, it's going to be parallel, and I want perpendicular. So that's the slope of this current graph, but I need a different slope to make a perpendicular line. So my new slope, okay, well, what would our new slope be? If the old slope is negative 3 over 4, then my new slope is going to be positive 4 over 3, right? If it's negative, it becomes positive, and then you flip that fraction. So here's my new slope. And I know the point that it has to go through. It has to go through the point negative 3, 1. So if it has to go through that slope and that point, then we're going to start in point slope form. So we have y minus 1 equals 4/3 x plus 3. Remember, in point slope form, your signs are going to flip. Okay, first step here is I'm going to distribute. Now I'm distributing because I'm starting to go to standard. So I have to start in point slope, go to slope intercept, and then standard. So we have 4/3 times x, which is going to be 4/3 x. 4/3 times 3, which is going to be a positive 4. And then my next step here is I'm going to get y by itself. I'm going to add 1 to both sides. Oops, I can't use yellow because I already used it in this one. I can use baby blue, right? Yep. Add 1 to both sides. So I have y equals 4/3 x plus 5. Now, this is in slope-intercept form. Now, normally we would stop here. However, what form do they want it in? They want it in standard form, so you don't want to stop here yet. Okay, the next step I would do is, in standard form, you know that x and y have to be on the left. Remember, there's 3 rules in standard. X and y on the left, a has to be positive, and you cannot have any fractions. So the first thing I'm going to do is move the x over to the left. Now I'm subtracting it because it's already positive, since I'm doing the opposite. Okay, so that's going to cancel. So then I have negative 4/3 x. Now what is this y? Is it positive or negative? That's a positive y, and then equals positive 5. Is this in standard form? No, there's actually 2 things wrong with this. The first thing is a is negative, and it can't be negative. And then the second thing is that we have a fraction present, and we're not allowed to have that present. So we have to manipulate this entire equation and multiply a number to it to get rid of the fraction and the negative. So I'm going to multiply everything by 3. Now, why did I pick 3? Well, when I'm looking at my fraction, I know that my denominator is 3. So I'm going to multiply by the least common multiple denominator. There's only 1. So I'll multiply everything by 3 to get rid of the fraction. And then I also have to multiply by a negative, actually, because this a is negative. So I want to get rid of the negative sign and the fraction all at once. So we're multiplying everything by negative 3. Negative 3 times negative 4/3 is positive 4. So we have positive 4x. Negative 3 times y is negative 3y. Negative 3 times 5 is going to be negative 15. All right, this is in standard form. And so I'm finished because that's what they asked from me, right? So what is important about perpendiculars, right? What is important about perpendicular lines? You do not use the same slope. Same slope means parallel. Perpendicular would be opposite reciprocal slopes. So it's pretty much the exact same thing as with parallel. The one key difference is you don't want to use the same slope. You want to make the opposite reciprocal. So there's just one extra step, but then all the other steps are exactly the same. And then when you're determining whether 2 lines are perpendicular or not, always look at the slopes, get y by themselves, and then see if they're opposite reciprocals of each other. If you have any questions, please feel free to let me know.